This episode is sponsored by Mel Science. Mel Science is a subscription service that offers monthly science boxes, which combine hands-on experiments with VR and AR technologies to engage kids in studying science. And we at Chemistry for Your Life think that's so important, and we are so excited to be partnering with them.
Just like us, Mel Science is breaking the stereotype that science is boring, difficult, and only for certain types of people. They're working to make science accessible and nurture children's natural interest in science by giving them fun, hands-on experiments to engage, serious, detailed explanations to learn, and VR and AR technologies to dive deeper. We love that. We actually received some Mel chemistry kits in the mail, and they're so cool. There was a real Erlenmeyer flask, as well as all the materials you need to do several chemistry experiments. I was so excited when we got it in the mail because it seemed so authentic. I was holding an actual Erlenmeyer flask like the kind I use in the chemistry lab.
To bring these cool experiments into your home and take advantage of a special discount for our listeners, go to melscience.com or click the link in our show notes and use the promo code CFYL. That's CFYL, like Chemistry for Your Life, to get 60% off of your first month. But this is a limited offer, so it's only available for 1 month starting today, so act quickly. And thank you again to Mel Science for sponsoring this episode.
Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life.
Okay, today's episode is actually kind of a prequel.
Okay. I like prequels.
Or maybe the first in a series, however you want to think about it.
Okay.
So it's been on my episode ideas for a long time, and I actually don't remember if someone asked. I think maybe it could have been my sister, Renee.
Mm-hmm.
I tried to search and I couldn't find it. So if that was you, give me a shout out and I will tell the world about your question in the next Q&R. But Adriana, the cosmetic chemist, and Sam Wise on Insta. So we have two Sams, one
right.
Sam in and one Sam Wise is how I distinguish them.
Right.
They requested two topics that are going to come up in the next few weeks.
Okay.
But I felt like we had to talk about clouds before we could talk about those things.
Okay, clouds. Nice.
So we're talking about clouds, and we're going to ask why clouds are white and fluffy.
Nice.
Really, why clouds float and why they're white.
Nice. And if you listen to this episode, by the end of it, you will be able to say with honesty that you have seen clouds from both sides now. That was like a music nerd joke.
I don't get it.
Sorry. I love one of my favorite songs in the world is Both Sides Now by Joni Mitchell. It's like an old song.
Okay.
And she talks about clouds as this sort of metaphor of seeing life from before and seeing it after kind of thing. So anyway, sorry for the unintelligible joke. Clouds are like this poetic thing in my mind often, but now we'll see it from the other side.
There's this subset of people who love that you made that joke.
Yes. And the three of you that love that I made that joke, please let me know.
Well, actually, this is kind of a timely recording that we're doing because it has just started to rain here.
Yeah.
And
hardcore.
I expect some thunder and lightning as well.
Mm-hmm.
So if you hear weird noises, we'll do our best to... Jam will do his best. I don't know, like I'm pretending as if I do any post-production to make sure it sounds okay, but just warning you that we do record in a house where the rain can be heard.
Yeah. Yep.
So clouds are essentially just a group of water molecules, basically.
Okay.
Hanging out in the sky close together.
Okay.
Or a pocket of really wet air is another way to think of it.
Okay.
So in science also, though, I should say, in science, when we say wet and dry, we literally mean water most of the time. If you're going to dry your solvents, it doesn't mean you're going to evaporate them. It means you're going to get rid of the water in them.
Mm-hmm.
So it's literally a pocket of air filled with water molecules. When I say wet air, that's what I mean.
Okay.
And I think on the surface, that maybe sounds kind of boring. Like, okay, that's what it is. But I think that doesn't do it justice because it's really actually magical and so much more complicated than that.
Okay.
Because if clouds are just pockets of air with more water, why doesn't humid air have that same white color that clouds do?
Right, right.
And how do pockets of more water areas float up in the atmosphere?
Yeah.
And how do they even form? And then how do they float, and stay floating?
Yeah.
And why does it look white? Most water that we see looks kind of blue.
Mm-hmm. Yeah.
And we've talked about on Why is the Sky Blue that small water particles scatter some wavelengths better than others, and that's why the sky looks blue most of the day.
Mm-hmm.
So it might seem like clouds are kind of boring, but I think they're actually really majestic and beautiful, both in practice when you're just laying on the grass looking up at them, but also in chemistry.
Okay, yeah.
So again, clouds are water molecules hanging out close together, but they're different than the water that's in the air all around us that makes it humid.
Okay.
So anyone who's ever walked outside on a humid day knows that there's water in the air.
Yeah, yeah.
My glasses fog up if it's really humid.
Yeah.
So that water in the air is in the gas form of water.
Okay.
So that's called water vapor.
Okay.
It's in this gaseous form. The water has turned from liquid to being a gas.
Right.
And as a reminder, solid, liquid, and gas, they're all made up of the same molecules. There's not a chemical reaction. But when enough energy is put into a solid, the molecules can move around more. They have vibrational motion and translational motion, and they rotate. And then they can start to spread out more.
Mm-hmm.
So it's like they can wiggle and they can run around, basically.
Okay.
And as they spread out a little bit more, they become water. And then as molecules spread even further around and have even more energy put in, then they become gas.
Right.
So it's basically just one molecule by itself with enough energy to hang out alone, kind of.
Right, right.
So that's just a quick review of solid, liquid, and gas. I know we've got into that more in detail in previous episodes. But water vapor in the air then has enough energy from heat and light from the sun to be able to spread out from its peers, right? It's by itself.
Yeah.
It's water vapor in the air. It's not associating with anyone else. And because the air that has water molecules in it is less dense, which essentially, if you took two containers that were exactly the same size, and in one of them you captured perfectly dry air with 0% humidity, and in one of them you captured very, very wet air with a high percentage of humidity, those water molecules make it less dense. So that would be able to float more than the one with just dry air.
Oh, really?
Wet air is less dense than dry air.
Wow.
And that goes into molecular weight and ideal gas laws. If you have the same volume of the same gas, everything being equal, it should have the same number of molecules in it. And if some of those molecules are water, water is a lighter molecule than, say, nitrogen.
Got it.
Or like nitrogen is 2 nitrogen, or oxygen, which is 2 oxygen.
Right, right.
So because of that, wet air is less dense. Humid air is less dense than dry air.
That's so interesting. I'm guessing just like atomic weight and molecular weight or whatever is what plays into that. But it's so funny because just my assumption, if you just asked me, like without studying it at all, if you just like gave me a pop quiz, would be that the humid air is more dense.
Because it like sticks to you.
Right. It feels like thick to go into, you know?
I think that's because you're feeling the water molecules, and normally your water molecules just evaporate right away into the super dry air. Right.
And it makes sense that like that, the feel for us as humans isn't actually like
the density.
The density.
Yeah.
But it just, I don't know. I think most people probably would make the same error I would have made, you know?
Oh, yeah.
But that's very, very interesting.
I know.
Huh.
So that wet air being less dense is able to rise up into the atmosphere.
Okay.
And as that rises up, as it gets higher and higher, the air gets colder and colder. And eventually, when it's up in the atmosphere, that water might find perhaps a nucleation site.
Ah.
So a nucleation site, we talked about in the snowflake episode and the Mentos episode, is basically a meeting point for molecules.
Right.
So if there's a little bit of dust or pollen or who knows what up in the air, then a few water molecules might congregate around that. And because it's cold, they might form a water droplet.
Ah.
So there we go. So that's the first thing.
Okay.
So if we have a few water droplets hanging in air, that's different because it's in its liquid form than water vapor in the air.
Right.
Okay. So these droplets are still very small and they're spread out, especially because there's less pressure from the atmosphere the higher up in the atmosphere you go, just like the more high you are on a mountain. Water boils at a different pressure, you have less atmospheric pressure.
Right.
So it's easy for them to spread out. They don't have a ton of pressure. It's colder, and then they find a nucleation site. All these things have to be just right, and then a cloud can form because there's a bunch of little water droplets in the air.
Yeah. Dang.
And they're not water vapor. They're literally liquid water droplets, but they're very, very small water droplets.
Interesting.
And that is how the cloud initially forms.
Okay.
Now, remember, these droplets are really small, and that's going to kind of affect the physics of what happens next.
Okay.
But the process by which these clouds are formed is called an updraft or a thermal updraft, where it goes up, cools down, condenses up in the air on a nucleation site, and that's kind of how clouds form, according to the meteorologist website that I found.
Yeah.
It wasn't a random one. It was a reputable source. It was the National Weather Service.
Yeah.
And an episode of the reactions by the American Chemical Society. But we're not meteorologists, so if there is a meteorologist, I actually reached out to one. I'm hoping can come on the show. But if there is a meteorologist who knows that that's wrong, feel free to reach out to me. We'll always take corrections. But that's what I found it was called. Now, as I said, once the cloud is up there, it's easy for the air to expand because there's less atmospheric pressure. So that actually kind of makes the wet air even less dense than the air below, because it was already less dense because it was filled with more water molecules than the other molecules. But also now it's got less pressure on it, so that helps it stay afloat.
Ah, yes.
It's even less dense. And if there are any small droplets that begin to fall, the other rising air sort of will push it back up. So all these conditions, just the right conditions coming together, will allow that cloud to form and then stay up there, stay floating.
Interesting.
Now, if you get too much water collecting and too big of drops, that's where you get rain.
Right, which is what we're experiencing outside right now.
Outside right now. The updraft couldn't maintain the water staying up in the air. It became too heavy. The water condensed and it falls to the earth as rain.
Right.
So that's how clouds are formed, and that's how clouds float up in the atmosphere.
Dang, that is not what I expected.
Yeah, there's so much chemistry there. And I knew it was water droplets because my mom loves meteorology, but I didn't really know. I didn't even think to wonder about how water could float up in the atmosphere by itself up there.
Right.
So weird.
Yeah.
Kind of amazing.
It kind of reminds me of this. So we've started taking my son to this little kids museum in town. They have this. It's not all the same, but it's just a little bit similar. They have this little wind tunnel thing.
Yes.
That's like this fan pointing up in the air, and you can stick stuff in it, and it goes up into the tunnel. And they have some balloons that you can put in there, and when it goes up, it'll actually hang out there.
Yeah.
It's like stays in that sweet spot.
Yeah.
And this particular one that he was playing with the other day, he could put one balloon up there, and it would stay there. He could put a second balloon up there, it would stay up there. They both were able to kind of stay in that sweet spot.
Right.
But when he put a third balloon up in there, they almost always all came down.
Yes, that's the perfect analogy. That is the perfect analogy. It's slightly different because the air has to push those balloons up.
Right.
If they were filled with helium and they rose by themselves and then they fell together somehow.
Yeah.
But that is a great analogy. Oh,
it's
my gosh.
An amount. I mean, the amount changing is part of it a little
Right,
bit,
yeah.
So, and then it sets the balance gets thrown off and
Yes.
it can't stay up. But yeah, that is exactly what came to mind. It's
amazing.
perfect.
How perfect.
We just went there the other day.
Thanks, Kid Museum.
Yes.
Children's science museums are one of my favorite places. Again, if someone wants to hire me, I'm just putting myself out there for jobs. I have a position for the next year. I'm very open after that. And working at a children's museum as a curriculum director has always been something that I thought would be really fun.
Oh, yeah. That sounds super cool.
So fun. Okay, so anyway,
Yeah.
back to it.
Sorry.
That's okay. Actually, you kind of did the Jim explains it back part already.
Yeah, I didn't mean to exactly, but I started, it was just a natural thought that I just had to come out.
Yeah.
In the midst of it, I was like, oh, I guess I'm kind of jumping the gun. But
no, I think that's perfect. That's a really good thing. And it's kind of good because I'm about to switch into why it's white, which is sort of a different chemical phenomenon.
Okay, sweet.
So this one was all based on the density of air. And density is weight per volume. So the weight per volume of wet air is lighter than the weight per volume of dry air, which helps it get up into the atmosphere in the first place. And then the nucleation site, which is something we've talked about a lot before, helps these droplets form, but when they stay the just right size, then they can float up on this less dense space.
Mm-hmm.
And then if too much water droplets or too large of water droplets happen, that's where rain comes in.
Right.
Just like your balloon.
Yeah.
Okay, but why does it look white?
Yeah, why?
Why? And we've talked about water diffracting light several times before.
Yeah.
And we're actually going to replay next week the episode about rainbows.
Nice.
Because we got a request for that episode. Shout out to Adriana.
Nice.
And we talked about in that case where it's sort of breaks up the white light that comes from the sun. So the light that comes from the sun is white, but it's made up of all the colors in the visible spectrum.
Right.
Red, yellow, green, the Roy G. Biv.
Yeah.
And rainbows form when that light is split up.
Uh-huh.
But when really small particles of water, like the water vapor in the sky that's not a cloud, whenever they scatter light, they scatter blue light further than other light. And that's why the sky looks blue to us most of the time.
Right.
Well, the size of these droplets and the shape of them make them perfect for clouds to be white.
Okay.
So they're bigger than those really small water vapor particles because a few of them have come together.
Right.
And they're perfectly spherical, unlike water droplets that have landed on the ground.
Right.
And so they scatter light in all directions. And they scatter all of the light. They're large enough particles that they cannot just scatter blue or red blue more effectively than red, for example.
Yeah.
They can scatter everything.
Got it.
And my understanding is since there's lots of them scattering the light is sort of all interacting and coming to our eyes as it being white.
Yeah.
But maybe if you could zoom in, I don't know how you could do this, but if you could get a special lens where you could see them all separately, I imagine, this is just my theory, that all the spheres would be splitting up all the light into all these different colors, which are then recombining and splitting up and recombining and splitting up and recombining, and that's how we see it as white.
Yeah.
So it's all the light is getting scattered. Now, maybe that's wrong. Maybe it all gets scattered as white light, but I imagined it sort of breaking it up.
Yeah.
But because it's just that perfect size and it's a sphere, so it doesn't only do the half arch like we saw, it scatters the light in all directions, and there's all these little ones doing that, then it hits our eyes in the combined state to look like a white cloud.
Dang.
And that's why clouds look white.
Interesting. Yeah, I always just assumed that like steam can look white, which is vapor. Obviously, that's already wrong. But like steam can look white sometimes. Ish. Like you got a pot that has some steam coming off of it that you're like boiling water.
I don't know. I mean, I think it is vapor, but I wonder if there's so many of it together that it does have that same thing where some of them are joined and they haven't fully spread out yet.
Yeah. But
then
then
that's
it's like,
why it looks kind of white.
So I always thought like, oh, it's a water gas cloud, which is like, it's not gas.
No.
It's droplets.
It's droplets.
Which then makes you wonder, okay, well, why is it white then? And then
really,
it's like,
really small droplets though, but not as small as water vapor droplets, which is like one water molecule. Kind of.
Yeah. And then it's okay. It's not gas. It's tiny water droplets. So then it's like, why is it white? It's like, oh, light being scattered equally in all directions kind of thing.
Yeah.
Which is crazy. But it's weird how you first undid one assumption I had, which then meant the other one didn't land either. You know?
Yes. Yeah. Isn't that amazing?
That's crazy, dude.
So it's like clouds are less dense air, rising, cooling, condensing. Maybe they're starting to fall down, but as more comes up, it like keeps it afloat, like the thing you said, until it gets too heavy, like the fan machine that your son plays with. And that perfect combination of events with just that right size of molecules then makes it to where we see clouds as white.
Yeah. Wow. More interesting than I expected for sure.
I know.
I mean, I still think clouds are interesting no matter what. Like I probably was going to be interested in this answer no matter what. But it was 2 curveballs that I didn't expect, you know?
That's fun. So I was going to have you explain it back to me, but I think you already did it in a way that's very helpful.
Sweet.
So you've earned a fun fact.
Okay, I'll take it. I love it.
If you condense all the water in the average cloud, it would weigh 1.1 million pounds.
Dang.
That's obviously an average.
Yeah.
And it's weird because it's all spread out and suspended. So it's obviously, it doesn't feel that heavy.
Yeah.
If you were to try to go hold the cloud, I don't even know what that would look like.
Yeah.
But if you condensed it down to a manageable space that you could put on a scale, that's how much all those individual water molecules together would weigh.
That is amazing. But it certainly makes sense a little when you think about when it actually rains and how much rain comes down. Like right now, it's like raining super hard.
Yeah.
So just imagine it raining this hard all across our entire town.
Yes.
That's a lot of water that would weigh a lot.
Yeah. And clouds are big.
Yeah.
They
it's
can
actually
be
it's probably
miles long.
Right. It's hard for us to even know tell from down here how big they are.
Right.
But yeah, that makes total sense, but it's still fascinating.
Yeah. So I love this. I thought it was cool. I thought the chemistry was as beautiful as the clouds themselves.
Yeah.
Like, I think if you just say it like, oh, it's a group of water molecules that are close together, that sounds really lame. But then when you think about all the complexity of a group of water molecules floating up in the air, then it gets really weird. And looking white,
yeah,
it just gets weird and very cool.
Yeah. Dang, that's crazy.
So that was a fun little adventure into the clouds. And I'm excited because we're going to do a little bit on rainbows, and then we're going to do lightning. And hopefully we'll have a meteorologist come by and visit us. Who knows? And so we're just going to spend some time in the sky for the next few.
Nice.
I'm pretty excited.
I'm excited too. I'm interested.
Speaking about exciting things, we haven't done this in a while because we've had a few long and weird episodes.
Right.
But as we're back into our groove, is there something happy that happened to you this week?
Yes. Well, I guess it wasn't exactly this week. It was a little over a week ago. But you might already know about it.
Uh-oh.
Because you and your husband watched our kid overnight.
Oh my gosh, that was so fun.
We received, for a few reasons, helping with wedding stuff for Melissa and Mason, we received a coupon for them to watch our son overnight. So for the first time in like almost 2 years, basically, Em and I had a night without a kid. Which is crazy. And got to go do some fun stuff in Dallas. Stayed at an Airbnb down there.
A night and a morning.
Yeah, and a morning. Yeah, night and morning. So basically like what most people who don't have kids get to kind of do a little bit of like Friday night, like fun, lazy Saturday morning that we don't really get to do as much. We got to do that for the first time in 2 years because Melissa and Mason watched our son overnight and in the morning. And it was super fun. It
was so fun.
Also eerie in the sense of like just like not having to be on duty as a parent, you know?
Yeah.
And anytime that like we were talking about this, there's been a couple times where either I've been gone overnight for some reason. So actually happened once only. And then there's been a few times that Em's been gone. Actually, a lot of times because Em works overnights right now.
Yeah.
Anytime either of us have had to be gone, the other one is the one that's watching our kid. So that is easier to feel like not worried, not thinking about it.
Yeah.
It feels more normal. That's common. But for both of us to be together, it was like, wait, so
who's watching our kid?
Yeah, exactly. That was kind of interesting and fun. And it was really cool. So that was definitely my highlight. What about you?
That was really fun. I'm not going to say it was my highlight, though, because you already talked all about it.
Yeah. And it gives you a chance to do your own, which is kind of like saying two, sort of.
Yeah.
So, yeah.
It was really fun, I will say. And also, it's weird, I guess, because we had my sister's graduation and my graduation. And so the week and a half, and then all these errands that had not been getting done and all this stuff that had sort of piled up, the week and a half after I defended was not a big rest. It was sort of a rest, but I was kind of all over the place, actually. And so that was the first night. We weren't at home, but we put your son to bed around, 8 or 8:30?
Yeah.
And then we just made dinner and went straight to bed.
Yeah.
And it was the first time we've just been able to do that. And then the next morning we woke up, we walked to a little coffee shop. It was so cute and fun. And we had a similar experience. It was like, when was the last time we just didn't have to go somewhere or do something or be away from, we were kind of away from home, but it kind of felt like being at home, you know, and we didn't have to stress about getting things done or packed or ready. We were just hanging out with the kid and each other. Mm-hmm. And it was really nice. So it was actually kind of fun for us too.
Yeah.
And that's actually what I'm going to talk about is I've been able to sort of rest some.
Yeah.
And I realized today I was going to get up early and do some work for the podcast. And I woke up early to see my husband go to work. I've been trying to get up with him now that I don't have work all the time anymore.
Yeah.
And I accidentally fell back asleep and I slept for about 2.5 more hours at least. And I woke up after that and realized it's the first time that I've just felt rested since probably early March. We did go to the cabin to write, and that was only writing and sleeping. So I was kind of caught up on rest then. But for the most part, I've just been tired.
Yeah.
No matter what. I mean, I have medicine, that helps me be functional and stuff, but I've just been tired. Yeah. And I realized today that I wasn't tired.
Yeah. Wow.
And so I don't know. That was just kind of this is kind of how it feels. It kind of goes along with that one. That was one of the first days that we had to sleep. And I was still tired then because it almost is like I was in a deficit because I had so much going on and I was so stressed. But it literally has taken basically a month from the day I finished my dissertation to feel caught up. I was still preparing for my defense and had some of that stuff, but I've just been celebrating and working and, so it's just, I feel rested for the first time today in a long time. I don't have a light layer of tiredness behind my eyes.
Yeah, that's awesome.
So that was kind of a fun realization. And I am going to try to take this summer to rest before I start my new job and feel like a sabbatical where I kind of put those habits of being a person again, like drinking enough water, cooking food at home. I mean, I don't know how to describe how much the function in our house shut down. We ate so much frozen pizza and I don't think I drank enough water for 2 months solid. Like it was I thought about work all the time. And so, and it doesn't have to be like that for everyone writing their dissertation. I was just in a unique situation where I had a hard deadline. If I didn't finish by then, it was going to cost a lot of money. Yeah. And so it just really was important for me to finish then for my mental and our financial stability.
Right.
And so it's just so nice to get to kind of recover from that and relax and watch people's kids. I mean, I basically hadn't seen your son for a month at least before that, maybe a month and a half. Because we were recording online because I didn't even have time to drive over here. Yeah.
Every minute counted.
Really and truly, every minute counted. Yeah. And so it's just nice to sort of feel like I'm a person again. So that's my happy thing is I'm a person again and I'm well rested and I've babysat 2 children in the last week. So that's been fun. And
dang. Yeah.
Yeah. Just seeing my friends and their families again has been really, really nice.
Yeah. That's awesome.
Yeah. Great. Well, this was fun. This was a classic episode. Yeah. Back to our old chemistry lesson type
Back to our old tricks, our old mischief.
Tricks. And I'm really excited for this series on weather and the sky.
Me too. Very much so.
So thanks to those of you who inspired this. Shout out to Adriana and Samwise for your good episode ideas and whoever originally put the clouds being white on my list 2 years ago. I finally got into it. And thank you guys so much for making it possible for us to talk about chemistry. I just feel so lucky to be able to do this every single week.
And thank you for doing it. Thank you for teaching us these cool lessons about chemistry in everyday life. And if you have an idea, like the people who helped us come up with this one and send this question in, you can reach out to us on Gmail, Twitter, Instagram, or Facebook at Chem for Your Life. That's Chem, FOR, Your Life, to share your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the cost of making it, go to ko-fi.com/chem4yourlife or tap the link in our show notes to donate the cost of a cup of coffee. If you're not able to donate, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. That also helps us to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jerem Robinson. References for this episode can be found in our show notes or on our website. Jerem Robinson is our producer, and we'd like to give a special thanks to A. Kiwasong and A. Collini, who reviewed this episode.